I am very happy to be here on this bright red spot on our pale blue dot, as Carl Sagan called our planet. Today I'm going to talk about gravity with a little levity. By gravity, of course, I'm referring to what's keeping you all in your seats right now, rather than floating up into outer space. But gravity is also an excellent example of how science can help us see the unseen. What got me thinking about gravity lately was this image. Now, one of the fun things about being a human is that you can take a whole bunch of us and put us in a room like this and show an image, especially one that's a little abstract. And we're all going to see something a little different. If you're hungry, you might see a donut. Now, you may have seen this image earlier. It was released, it's a black hole, the first ever image of a black hole released thanks to the Event Horizon Telescope team, and of course, many, many great thinkers that came before them. And for me, it brought back a lot of memories because back when I was in college, majoring in physics and computer science, I worked at the Jet Propulsion Lab in Pasadena doing similar radio astronomy research. And we used a technique called very long baseline interferometry, which is fun to say. That's right, I speak geek. I'll talk nerdy to you. So I was especially interested in seeing how the technology had evolved since then, but I was also excited to see how we humans had gotten better at communicating complicated ideas like this to each other. Thanks largely to TED and TEDx, there's all kinds of videos from venues and voices all over the globe about black holes. But in spite of all this advancement, some of my friends were still confused on a couple of points related to this image, specifically how it's not a photograph exactly in the way you're used to thinking of a photograph, and it's not really orange. So I'm going to come back to these two knots later. But first, what is it? It is a black hole in a galaxy far, far away. 55 million light years. Now, if you're not used to thinking of distance in terms of how far light travels in a year, that's like a 3 with 20 more digits after it, very far away. It's super massive because, like all black holes, its gravity is so strong that not even light can escape. Makes it a little bit hard to see. Also, because the gravity is so strong, if you get an object close to it, for example, if you had a banana, it's going to experience something called spaghettification. This is a real word, I didn't make it up. So what that means is it's going to stretch and contract and stretch and contract and stretch until finally it just poof, disappears into the black hole forever. Now, the circle that you're seeing is due to the event horizon, and that is essentially the point of no return for all light and bananas and so forth. And although this was predicted by relativity a long time ago, this was the first time we could ever directly observe it that closely. So that's why this made headline news all around the world and won awards and why everyone was so excited. So I'm hoping that the next time you see an image like this, or a donut, and there are a few more coming, they're crunching the numbers on a supermassive black hole at the center of our own universe. I hope you'll think, wow, aren't we lucky little humans because we have science to help us see the unseen. Now, I say lucky little humans because, well, everything's kind of little compared to a black hole, but also little relative to, say, the dinosaurs who were wiped out by an asteroid. They weren't paying attention to what was going on in the sky. So we can avoid this fate as humans because we know how to do calculus. Woo for calculus. So back when I was a much littler human being growing up in Hawaii, before I learned about calculus and Newton's laws and relativity, I learned a little bit about gravity from a canine on TV. Does anybody remember Wile E. Coyote and the Roadrunner. So he would go running across the cliff, and it wasn't until he realized his predicament that gravity would kick in, at which point he would fall straight down. Now, is this how gravity really works? No. You may recall from school, we had Newton's laws, which would predict a path not square, but rather rounded. Now, one of the things about Newton is he grew up where there was a bunch of apple trees. I don't know if you remember this about this story. Apples would fall from the trees and give him ideas. So I grew up in the tropics, and we didn't have too many apples, but we did have lots of bananas. So we could do a simple experiment like good little scientists and see which really happens. Is it the square path like the coyote showed us, or is it the curved path like Newton predicted? Are you ready? We're going to do a little experiment. So if I send something this way, what's going to happen? Woo! Yay! Yay for Newton. So when I'm learning about science, it's fun to know a little bit about the story of the person who discovered this. You know, Isaac Newton invented calculus, not to torment students, but to figure out questions just like this. He also had a bunch of fun quotes. For example, this one's pretty famous, where he said, "If I have seen further, it is by standing on the shoulders of giants." Now, this is one of the things that to me was very appealing about science, is how we help each other. You know, there's this collaboration across cultures and time, and also this dedication to finding the truth. But wouldn't it be nice if we also had this kind of humility in other parts of society and dedication to truth? Unfortunately, Newton's laws could only take us so far. They worked great for things like bananas and asteroids, but if you had something moving a bit faster, like a GPS satellite, or something much more massive, like a black hole, you were going to need a more general theory, like the general theory of relativity. And what this tells us is that rather than some invisible force pulling down on the banana, it's actually space-time that is bent by mass. Now, it's hard enough to comprehend three-dimensional space. Never mind, you add a fourth dimension on top of that and say that it's not static but moving and wiggly. We have gravitational waves. This is just mind-bending, and it would take a genius to come up with it. Now, you might know who the genius was that came up with it. Anyone? Einstein. Aha, but which one? There were two. She says. Really, I promise, there were two. Oh, there we go. The seen and the temporary unseen. Mileva Einstein was Albert Einstein's first wife, and they met in school. This was a college that didn't normally allow women. She had to apply for special permission to go. There's quite a bit of evidence from people who knew them and from their letters that showed a lot of collaboration. Her name was even on an early version of one of their papers. It was removed before it went to be, officially published. So we'll never know for sure how much collaboration happened there. Fortunately, we've gotten a little bit better at being inclusive and giving credit where credit is due. We still have a long way to go on that front. Luckily, we don't have quite as far to go on our image. It would take a few more science giants to get here, because even though Einstein's theories predicted the existence of a black hole, he himself couldn't see it. He thought that was just bananas. That was too crazy to be something real. It would take other science geniuses to come along and say, oh, well, this thing could really happen, and how can we find it? And then come up with very long baseline interferometry in the 1960s, which takes me to those two no's that I promised you earlier, how it's not really orange and not exactly a photograph in the way you're used to thinking of a photograph. So that comes back to light. Now, do you guys remember your electromagnetic wave spectrum from school? Light comes in all sorts of wavelengths, and unless you have superpowers like X-ray vision, you can only see in this very narrow spectrum here in the middle where colors exist, okay? And that actually doesn't work very well for observing the sky, except for at night, because the sun is blasting out all this visible, colorful light. So if you choose a wavelength further down on the longer wavelength spectrum, you can see better. And so if you have a which you might be used to seeing, like our local Palomar Observatory optical telescope, like you can see here on the right, it looks a bit different than the radio microwave end, which looks more like your satellite dish, which also works pretty well during the day. So that's essentially why it's not really orange, because we weren't looking at in that spectrum, and it's not exactly a photograph, because it takes quite a bit of post-processing to take the not just one satellite dish, but a whole bunch of them from all over the world, to combine that data and then to subtract out our own human bias makes it not exactly a photograph. And for the not exactly orange part, it's a bit like when you look at the weather and it shows you a map of, like a storm and it's red. It's not really red rain falling down. It's not meant to be taken literally. For example, here's one from a recent hurricane that shows a bunch of different colors. And this is also over several different days, as is the black hole image there. So not meant to be taken literally. And on the radio telescope image, they essentially decided to use these colors to represent brightness temperature. So what I'm trying to tell you is that the Event Horizon Telescope team decided that orange is the new black hole color. But there's still a big hole right here in the hole. We don't quite understand what's going on there. You could be the next science giant. We also haven't quite figured out how to combine relativity with quantum mechanics. So in order to think like a scientist, all you have to do is come up with a cool acronym. Be a genius with the clicker. And remember to work together. So many studies have shown that diverse teams are much better with creativity and discovery. Remember to be objective and test if you can with a banana or whatever, what you see in the media. And don't trust, especially if you see a canine on TV. And then remember to be wild-eyed with wonder like you were when you were a kid. And it's okay sometimes to go a little bananas. Last one. So, oops. I work on my throat. But I encourage all of you, whether or not you're scientifically inclined, to think about, what kind of giant you want to be. Who are you going to elevate so that they may further see? And then, whose shoulders have you stood upon or next to? And did you give them enough credit? And did you remember to say thank you? Thank you.